For our project, we researched how to determine the congestion of campus spaces with crowd counting. So the motivation for our project is that public spaces on the UC Davis campus can get very crowded, which makes it difficult to find places to sit. We wanted to make it easier to find available seating, especially during busy periods of the day. And we were hoping to find a lightweight computer vision model that could take an image as an input and output how many people can be seen. This type of model could be used to predict where open seats will be, which could save people a lot of time. We used the crowd counting dataset published by Francisco Mena on Kaggle. This dataset contains images from a shopping mall with various numbers of people that can be seen in each of the images. The labels contain a single integer representing how many people can be seen in the image, and it's important to note that the labels contain no information about bounding boxes. There are 2,000 images in total, each 640 by 480 pixels, and we split the data into 1,400 training images and 600 testing images. Some pre-existing approaches that we considered were YOLO, or You Only Look Once, RCNN and faster RCNN, which involve identifying regions with specific objects, SSD or single-shot detection, and RetinaNet.
Since our dataset didn't have bounding boxes and we only were focused on having a single number for our reporting, we instead implemented 5 approaches, which were a classification CNN or regression CNN, pre-trained YOLO model, which we used as a baseline. And then we also tried training the ResNet50 model with transfer learning to achieve better results. Our classification CNNs used cross entropy loss, Atom as the optimizer, and a learning rate of 0.001 to compare a probability distribution for 60 outputs, one for each person, while the regression versions had a single output. For the results, we mostly focused on mean average error and the number of people missed, and you can see that YOLO V8 did not do very well, probably because it suffered from occlusion, and the linear regression models fared much better than the classifier models. And we also did see an improvement using transfer learning. We also have an additional way to visualize the accuracy of the ResNet50 transfer learning model, which is a scatter plot of the predicted values versus the actual ones. And if it was perfectly accurate, we would expect the distribution to match the y equals x line. And it does that somewhat well, although there's definitely outliers, especially when there's a lot of people in the image.
While we were training our CNN models, we ran into the problems of non-convergence and overfitting, as you can see from the very unstable training graph on the left. To fix this, we added batch norm layers, dropout layers, and decreased the learning rate in the optimizer. The ResNet50 regression model performed the best, and it also saw minimal overfitting. Overall, the regression architectures did better than their classification counterparts. The only model that did poorly was YOLO, which was unable to count people effectively. Obviously, though, our models have their own limitations. For our CNNs, the vanishing gradient problem still occurs. We also tried a lot of learning rates and batch sizes during training, and a lot of them resulted in the model converging too slowly, if at all. Our models don't predict bounding boxes, so they can't be trained on datasets with bounding boxes. All of our models are trained on images of a single shopping mall, which leads to poor generalization. For further improvements, we can always have a larger and more diverse dataset. We can conduct data augmentation before training, and during training, we can improve hyperparameter tuning with techniques like grid search or Bayesian optimization. We can use cross-validation and early stopping to prevent overfitting. We can use transfer learning on other architectures like mask RCNN and faster RCNN. And finally, we can expand the functionality of our models to bounding boxes as well as other features like instance segmentation.